Good afternoon, everybody. My name is Clark Wenzel. I'm a Senior Product Manager at AWS AI, and I'm really excited today to talk to you about AWS DeepRacer. So let's look a bit at our agenda. We're going to cover what is DeepRacer, why did we make it. We'll then dive into a league recap, and following that, we'll give you a bit of a Sunday driver tour through reinforcement learning, just to sort of set the scene and help you understand some of the terms and things we'll be discussing later on in our hands-on lab. We'll give you a quick overview of the virtual simulator, just so that when you see it, you're familiar with the items that we'll be discussing. And lastly, we're going to finish off with that lab. So, where does DeepRacer come from? Well, in 2018, we launched AWS DeepRacer to try and get developers hands-on with reinforcement learning. And we did this because the prior year, we launched a product called Deep Lens. And this was the first of our AWS AI educational devices, designed to get developers hands-on with building their own image recognition models. Now, last year, SageMaker wanted to launch reinforcement learning. And so we said, well, how do we actually go about getting developers hands-on with reinforcement learning? Taking the approach of trying to teach an autonomous car to race around a track seemed like a pretty fun and exciting idea, and the team were all in. So, DeepRacer. It's a 1/18th scale autonomous race car. We have a virtual simulator in the AWS console, and we also have the DeepRacer League to try and get developers more engaged with the product and to throw a bit of a competition out there to see who can build the best autonomous race car model using AWS DeepRacer. And what you'll see on screen there is a mock-up of our virtual simulator as the car is navigating around one of the tracks. And you'll see that in action live later in the hands-on demo. So, under the hood, what is happening in the car? Well, as you can see, there's a whole bunch of electronics built into this RC car. It's not a typical RC car. We have a 4x4 robot, 4x4 monster truck chassis. On top of that, we have an Intel Atom system on a chip. And that's basically where all the magic happens. The car drives around the track. It takes about 15 images per second. And those images are then sent to the model that you trained, at which point we run something called an inference on the images. And inference is just a fancy way of saying I'm basically pushing this image through a function and it outputs an action. And that action we'll get to later is basically the action that the car is taking on the track. So it will decide purely by looking at a track what action it should take. Cool, right? And you get to train that model. Before we get going, let's get a quick recap of the AWS DeepRacer League. So what is the league? Well, it's the world's first global autonomous racing league, and there are two ways in which you can race. The first one is in our virtual circuit happening in the AWS console right now, and the second one is in the Summit circuit at selected AWS circuits. So it wouldn't be a race without a prize, right? You can win a trip to reInvent where you can take part in the knockout rounds to see if you have what it takes to progress through to the Championship Cup final. And winners will also win an AWS DeepRacer car. So, the Summit circuit. We've had 21 races thus far across 17 countries with thousands of developers of all skill levels. And we've seen a world record of 7.44 seconds. Now, I've never seen a more consistent model in all my life. This record was set by Sola as she powered her model around the racetrack at the Tokyo Summit in Japan. We also have the virtual circuit, where we've had 5 races thus far, all shown on screen, and at the moment you can take part in the Toronto Turnpike, and it's now open. So, hopefully at the end of today's session, you'll be able to go in, create your own model, and from the comfort of your own home, take part in the AWS DeepRacer League virtual circuit. So all of this has been for people to take part in the AWS DeepRacer League and win an expenses-paid trip to reInvent. So let's take a look at the road to reInvent.
In the past few months, AWS DeepRacer blazed a trail around the world, crowning champions at every summit and every month online in the DeepRacer virtual circuit. All of our winners earn an expenses-paid trip to AWS reInvent in December to compete for the most coveted prize in machine learning, the DeepRacer Championship Cup.
Competition starting to heat up. It's getting tighter at the top of the leaderboard.
I want this trophy in my desk.
In the waning moments of the Amsterdam event, mountain biking champion Jesper Slick posted a winning 13.03-second lap.
Right on cue, a new fastest lap. How about that?
With the help of his Pond Data Lab partner, Casper Mayer.
Ladies and gentlemen, we're about to send off our first racer in the Sydney leg of the DeepRacer International Autonomous Racing League.
In Sydney, Matt Carrison, representing the Brisbane-based company GJI, won his spot at reInvent with a photo finish in 8.29 seconds.
After consulting with the judges, we have a time of 8.29 seconds.
Win here today would mean a free trip to Vegas. That's the only reason why I'm entering, right?
And in the last few minutes of the London event, Matt Camp of Jigsaw XYZ defended founder Rick Fish's 2018 DeepRacer Championship with a scorching lap of 8.91 seconds.
New number one, Matt C.
Those three will be joined in Las Vegas by our 18 other AWS Summit winners, our 3 top overall point getters from the Summit circuit, and our virtual circuit champion. Carl from National Australia Bank won the London Loop with a time of 9.739 seconds, and Fumiaki Ono took the Jun Kumo Toraku with a time of 10.312 seconds. But as the field takes shape for reInvent 2019, there's still time for you to win a spot in Las Vegas by competing at an AWS Summit or in the virtual circuit, where there are still spots not only for the winners, but the fastest 18 racers overall. And we've got some special twists in store for all our qualifying racers at reInvent.
We kijken natuurlijk heel erg naar uit om de rest van de wereld te laten zien wat wij Nederlanders kunnen.
We want to represent Australia and take home the gold.
You guys are going to have to go really fast to beat the London crowd.
Don't miss out on your chance to compete for the Championship Cup. And don't forget to like, comment, and subscribe to DeepRacer TV on YouTube. And now you can find the entire season of DeepRacer TV on Amazon Prime.
And just so we track on time, one thing that we have to do now is we have to go and create account resources. When you navigate to the AWS DeepRacer console, please go to the US East 1 region and find DeepRacer. And let's see if we can do that for you. Here you will see the AWS console. Let's maybe go out. And I am going to find AWS DeepRacer. If you can navigate with me, that'll be great. And do make sure that it says North Virginia on the top right. And so I'm going to AWS DeepRacer. And once I'm in the service, I can go to get started with reinforcement learning. And now I've not done this in this account. This is a good one. Here I want you to select create resources. And so once you click that button, it's going to take roughly about 5 minutes. And what's going to happen now is the service is setting up the IAM roles in order to call some of the dependent services that we'll be using later on. And it's also creating the required resources stack, which we will use to execute the training jobs. And this is a VPC stack required for the communications, and we'll talk about that once we get to the actual virtual architecture. Now you can let this run in the background. We're going to go back to our slide deck, and it should be done by the time that we start the hands-on lab. So let's take a journey through reinforcement learning. We'll start off thinking about AI. What is AI? Artificial intelligence seeks to create machines that seem to have human intelligence. And this is a very broad and general concept. And so we'll narrow it down a bit and we focus on something called machine learning, which is essentially trying to build a statistical model to try and make some prediction. Now we have a number of these statistical techniques that we'll look at. We have reinforcement learning, we have supervised learning, and we have unsupervised learning. So just diving deep on those. Supervised learning is very much example-driven training. So you would provide a data set that has been curated by experts, and you will train a model to try and replicate the expert knowledge from your expert. You have unsupervised, and this is typically where you don't really have labels for your training data, but you think there's some sort of a pattern that exists in your data. And so a good example of that is typically something like clustering. And then we also have reinforcement learning. And this is primarily what we'll be focusing on today. Now, the key difference between supervised learning, unsupervised, and reinforcement learning is in supervised and unsupervised, you have to provide a whole lot of data to build your model. Whereas in reinforcement learning, we provide an environment in which we can automatically obtain the data. And so we'll tease that apart as we go through the next few slides, but that's a key difference here. It's essentially in reinforcement learning, we are not going to be providing data that's labeled by some expert. So let's look at reinforcement learning in the real world. The easiest example is think about training a pet. If you want your dog to sit, you'll typically say sit multiple times, in my case thousands of times, and eventually your dog will realize, hey, if I do something which corresponds to sitting, when I hear sit, then I get a reward. And obviously it doesn't help if you reward your dog for doing bad things, so we won't be doing that at all. And then what happens is eventually your dog turns into super dog and can sit on command. I've seen this in action with a buddy of mine who trained a Labrador, and it was really a work of the art. He had a lot of discipline, and I think that's sort of the thing we're gonna pull across into our own models is we are going to provide the logic that essentially tells our model what is good and what is bad from an action point of view. So let's look at some key terms that I'll be using quite often throughout the workshop and throughout the rest of this presentation. So we have an agent. Now I mentioned earlier on that in reinforcement learning we do not provide a whole bunch of data, but we generate that data from an environment. Now, the agent is that piece of software, if you want, or that system or car that drives around in a virtual world and essentially interacts with that world. And that generates the data that we need. Now, this world or environment, in our case, essentially is a simulated racetrack. And then we also talk about a state. The state is simply when our car or our agent is driving around and they're taking a picture of our environment. That is the state. It is what they know of the environment at this point in time. And then every time that they take an image of our track or observe that state, they then decide what action to take. And an action is really as simple as the car is deciding how fast or how slow it should go, and whether it should turn to the left or to the right, and what sort of degree it should turn. Now, after each action, there is a reward. Similar to our pet, where we provided a nice treat, in reinforcement learning, a reward is typically think of it as a numerical, it's just a numerical reward. You get a 1, you get a 5, you get a 10, you get a 0. Obviously, the size of that reward is really important, and the reward function is something we'll talk about shortly. It's a pretty key concept. you'll see something called an episode quite often. Just think of it like this. Our car is exploring the environment, but obviously our car can go off track and do something that we don't really see any value in doing. And typically what we would do then is we would reset the car back on the track and say, okay, let's start again. And so from the starting point to the reset point, that is typically called an episode. So the reward function. This is a really important concept in reinforcement learning. The reward function is really the thing that incentivizes the driving behavior in your model. So we'll get to let's look at a good example now. Let's look at a reward function in the context of a grid race. And so here in front of you, you'll see there's a racing grid with our car starting on the left, and it needs to make it to the goal all the way on the right. We need to go and build a model to help the car move all the way from the left to the right. And the way we need to train this model is simply by providing a reward function. And that reward function will aim to reward the car if it exhibits the correct behavior, and it won't reward it if it doesn't exhibit the correct behavior. And so a really, really simple example is we can actually say, hey, the shortest distance between 2 points is a straight line, so let's just incentivize our car to drive down the middle of the road. And the way we've done this is to say that if our car is in that middle square, or that middle line, we will reward it with a 2. And if it deviates, we're going to give it a lower reward. We'll still reward it because it will likely continue in the right direction, but it's not going to be a high reward. And so here we basically start approaching, I guess, the concept of how do we train this model? Well, our car is now going to be exploring our grid world. As I mentioned, there's going to be a whole bunch of episodes. We're going to start it off on the left-hand side and say, you can go and explore this grid and randomly choose actions as you see fit. And after each action, we'll simply look at what corresponding square did you end up in, and we'll give you a reward. And so here you can see that our car decided to go sort of left and then it veer off to the right, crossing the middle line. But in general, it didn't really get to the point of sticking on the middle line. But that's fine, because this is only the beginning. The model that we have here really doesn't know anything. And so what we need to do is, over time, we'll see that this car of ours, or this agent, is exploring multiple paths. And what's happening is each of those paths represent an episode. And that episode really represents the experience and, in fact, the data that we're interested in modeling. And so what just happened there really quickly online or on the screen is our car learned from past experiences that, hey, if I want to maximize the cumulative reward that I get, I can do that by simply following that straight line down the middle of the road. Let's see if we can play that again, because that's pretty good. So here we can see our car is exploring, and it's exploring. And as it gains more experience, it's trying to find that path that will maximize the cumulative rewards. Okay, here we'll look at two concepts, one called exploration and the other called exploitation, and it will introduce us to a third concept called conversions. So what do we have? We have a car that is veering off the road at every possible opportunity, and there's a perfectly good explanation for this. The model is still figuring out what to do. It hasn't really learned anything. So it's taking an image, taking a picture of the track, and then deciding randomly at first to try, to take an action. Which is why when there's a straight ahead of it, it'll just go and veer off to the right or to the left. And what we'll do is we'll basically capturing all this data. And now as we have more and more of this data, our car is trying to figure out, well, if I want to maximize my cumulative reward around the track, what should I really do? And so over time, our model is moving from something called exploration to exploitation. it's now learned that there are actions that actually lead to a higher reward. And what we can then also say is that at this point, when we start seeing our car race around the track without going off track, we've reached a point of convergence. And so let's cut over to Blaine Sundrad, our resident AWS DeepRacer expert, for an explanation on what is convergence.
There's a certain element in machine learning that's a combination of exploration and exploitation. Think about training a dog. A dog is going to, for the first while, not really know what you're asking the dog to do, so she'll try jumping up and laying down and doing things to get the treat. That's an exploration phase. In DeepRacer, that's the car driving into the grass or going really fast in a straight line. It's trying to experiment to see what it is and then see, did I get rewards from it? Then it moves into an exploitation phase where it knows it's got a good path. That convergence from what happens if I do something to I really like doing this thing, that's convergence. But that takes time.
So, how does learning happen? Well, it's an iterative process, clearly, because we go from a car that doesn't know how to drive to one that knows how to drive. But that doesn't just happen in one training. Our car initially doesn't know anything, it's randomly taking actions, and as you can see on the screen, it's working in that environment, exploring, taking actions, getting a reward, moving to the next state. And once we've collected enough episodes, and that's a hyperparameter, don't worry about the word called hyperparameter, we'll talk about it a bit later, but once we've collected a certain amount of experience, we will start training our model. And once we've trained that model, we will send the model back to our agent and say, hey, we've learned something now. We think you should look at this and use it to go and collect more experience. And this is also where that whole exploration, exploitation comes in. Initially, you really want your agent to explore as much as possible, because how else will you know what is the best route to follow? But as you start getting better and better, then you want to turn down the amount of exploration and you want to go into exploitation. We've now seen all the possible routes, or potentially all of them, and now how do we figure out, or how do we make the best use of what we've learned? And so this training is an iterative process. In DeepRacer, it can take anything upwards of 60 minutes to try and get a model that is reasonable, depending on your hyperparameter settings. But we'll cover those once we get to the hands-on lab. So, how do we actually train this model? During this model training process, what is happening in the background? Well, we use a reinforcement learning algorithm called a policy optimization. There's generally sort of two key methods that you can use to train reinforcement learning models. The one is a value approximation method, and the other one is a policy optimization method. And so here on the left, we have our simulator using the latest model that we've trained to get experience. And that experience is fed into our experience buffer, and that then feeds into our policy optimization algorithm. And so all of this happens in SageMaker, and we'll start talking about the architecture a bit later. So here we take a look at the neural network architecture. This is the model that we'll be training. And so on the left, we have as input into our model the images, the states that the car, the images of the track that the car is taking. And those images are fed into something called a convolutional neural network, which basically doubles or exists for the purpose of extracting useful features out of our images. So think of it like this. Our model is trying to learn what should it be focusing on in an image in order to best decide what action to take. And so one such feature that you want your model to learn is, where are the sides of the roads? Now this obviously draws back to what is a reward function and what are we rewarding the car for. So clearly if we're rewarding a car for following the center line, we hope that our model is learning something that if I see a specific marking, this typically is the center of the line. And that's called feature extraction. And all of that is done by our convolutional neural network. After our convolutional neural network, we basically combine all the nodes and we create a thing called a fully connected layer. And that is what you see when you look at the section called policy network. And the final output from this is essentially our action space. If we tell the car that you've got 5 or 6 possible actions, then once we run an image through a model, it'll output all the actions and provide a probability for each action. And simply the car will select what is the action with the highest probability, because that is the action that the model thinks will maximize the cumulative reward that the agent can obtain. So let's quickly dive into the virtual simulator. How do we make this all happen? Well, AWS DeepRacer is built on top of various AWS services. We have Amazon SageMaker, that is the key system we use to train our reinforcement learning models. We have AWS RoboMaker, and that provides the simulation environment, which you will see later. This is the environment in which our agent goes to try and pick up as much experience as possible. We store our trained models in Amazon S3. We use Amazon Kinesis Video Stream to stream video directly from this cloud-hosted simulation environment to your local browser. And we also use Amazon CloudWatch to store a number of logs and useful things that you can go and analyze after training. Let's take a quick look at the AWS DeepRacer service in the console. At this point, the most important thing for you to know about is programming your own reward function. Getting started is really easy. It just takes a bit of syntax, Python syntax knowledge, and we've even added a validation function in the console. And so, as I mentioned, this reward function is really the most important thing at this point to try and help our model learn the best driving behavior. And the reward function is essentially the logic that you will provide to help the car discern what is a good action versus what is an action rather to be avoided. And so to get you started, we provided a couple of example reward functions. And as I mentioned, this validation function, so that if you go and make changes, we can catch any errors before you start a 1 hour, 2 hour, or a 3 hour training job. When you think about a reward function, you really should be thinking about what are the driving behaviors that you want to incentivize. And for you to think about those, it's important for you to think back to the simulation environment. If you think to driving on a real road, it's very simple to say a good outcome is staying on your side of the road. And so you need to have this concept of there is a road and there are two sides to the road. And that's a similar concept in DeepRacer in the simulator. We basically have a number of parameters in our reward function that gives feedback to tell us where exactly is our car on this track and what is it doing. And so looking at the screen, you'll see we have this concept of a track wall. We have what is called off track, that's the green part, typically the field. We have the track surface. We have some boundaries, the white lines, and we have a center of the track, the yellow dotted line. And looking at an aerial view, we can see that we can easily determine the XY location of our car at any point on the track. We know what the width of the track is. We can even calculate the heading of the car. And to help make learning smoother, we've provided a set of waypoints for each track. Now, one thing I need to clarify here is that what is a waypoint? Well, a waypoint is simply an XY marker on the track that tells us where is the middle of the track for any XY combination. That doesn't exist in the real world. It's purely in the simulator. And its sole purpose is for us to figure out, is your car on the track or is it not on the track? Because we know the width of the track, we know the waypoints, so we can quickly figure out whether your car is on track or off track. I'd say waypoints are also useful if you want to go and play with a reward function to say, hey, I know what my current waypoint is, I know in my next 3, so I can potentially calculate what is the angle or the heading from my waypoint to the next. And you can basically reward your car if the steering is in that direction. Now, when you think of it like that, it's not going to be the same in the real world. Remember, the key thing here is you want to incentivize your car to learn the right driving behavior. So think of it like this. My car is going to take an image with a camera, and that image is going to be fed into a computer, run through a model, and it's going to spit out an action. So your reward function really should be thinking, am I rewarding the car now for something that it can actually learn by looking at the image? So if there is a turn, it kind of makes sense to sort of reward your car for either, exhibiting some behavior that you would see in the real world when approaching a turn, such as perhaps slowing down in front of the turn. And that's something that you can do with the reward function because it's just a piece of logic. So that's something that you should be considering. Now, here's an example of distance from the center. This is a variable that we provide in the reward function, and as you can see, we simply measure what is the distance from the center line. And so in our most basic reward function, you will see that we try and incentivize the car heavily to stay in the middle of the road. And so we will scale the reward. The closer you stay to the middle of the track or the center of the track, the higher the reward. And the further you move away from the center, the lower the reward. And this is something that you can do as well based on things like steps and progress, etc. There's some really interesting reward functions out there that some of our most frequent racers have shared with the community. So I can advise you to maybe go and have a look at those as well. So action space. In our simulator, we let you decide what the actions are you want your car to take. And this could be something like, well, how sharp do I want my steering angles to be? Or how fast do I want my car to go? Or how many different steering angles should there be from left to right? Or how many different speed levels should there be? I don't want my car to just, have a throttle of or 5 meters a second. I want it to be able to do like 5 meters, 3 meters or 1 meter a second. Hyperparameters. You will see these in the console, and I think they're worth reading through. I'll call out some really interesting tweaks that you can do once we get to the hands-on lab, because there are ways in which you can make learning happen faster. And that's the first one is obviously learning rate. The way you should think about this is, I have a model and I run training iterations, or I collect experience, I then retrain my model and I collect more experience. Well, every time that I update my model, by how much do I want to update it? That's typically what the learning rate refers to. It says that if you see something new that is good, how much of that do you want to incorporate into your current model and basically sort of, override what you've seen in the past? Do you want to immediately take into account all the new good stuff? Or do you want to perhaps say, well, I want more iterations where I see that behavior, and hence I want to use a smaller learning rate, which will make learning take a longer time. There's obviously a whole bunch of pros and cons for each of these in moving them in a specific direction, and I highly recommend that you go into the AWS DeepRacer documents. There's a link at the top of the screen now, docs.aws.amazon.com/DeepRacer, where you will find a whole list of pros and cons for each of the hyperparameters. Cool. And with that said, let's jump into our hands-on lab But before we get there, just in case we run out of time, I do want to point you to these really, really useful resources that you can find on AWS DeepRacer. The first one is a shout out to the AWS DeepRacer Slack community. The link is at the top of the screen. If you are interested in learning more about DeepRacer and seeing what the community has done to join some community events, please join the Slack channel. I think you will really enjoy this. There's a lot of collaborative learning going on, and it's a pretty big community. Secondly, we have our GitHub link, which you will find on screen, and we're going to work through it now. We also have a video course. This is by our resident expert, Blaine Sundrat, and he will take you through everything needed in order to build a model and more. We also have racing tips. This is a section where we provide useful tips that we've picked up from the community. For example, say you want to create your own track at home, or say you want to really improve your model for the virtual league. That's all, that's all covered in our tips section. A good call out there would be there's something called the log analysis notebook. You will find that in Racing Tips to really try and help you see what did your model learn, like what is it focusing on as it drives around the track. We have the documentation, and we will have the AWS DeepRacer forum. So, to get started with this hands-on lab, I'm going to be walking you through our GitHub page. The links are on screen now. What you can do is you can search for AWS-samples on GitHub and then find AWS-DeepRacer-workshops. You may want to screen grab that. Okay, and then you're going to navigate to Workshops 2019 and Lab 1. So what I'll do now is I'm going to basically walk you through creating your own model. I've now navigated back to the DeepRacer console, and we can see that our resources have been created, and I'm going to go to reinforcement learning. Now, I've trained a whole bunch of models in preparation for this, and we can look at some of the results now. But before we do that, let's maybe just kickstart a model. So the first thing we want to do is you want to select Create Model. And here you will find a whole bunch of interesting things around what is reinforcement learning, how does it work, and we also have a really handy information bar that you can pop out on the right hand side, and that is available whenever you see these blue info buttons. Now, as we scroll down, let's give our model a name. Test 1, 2, 3 seems appropriate, and I want to select a specific track that I want to train on. Now, you'll see tracks, actually you'll see quite a lot of tracks. You'll see tracks from the reInvent 2018 track. This is the track that we use for summit racing. So if you fancy training a model to go and take part at reInvent, when there actually will be a 20-second race, and we'll speak about that, this is the track you want to use. We have tracks for our Toronto Turnpike, Cumulo Carrera, Shanghai, and all the other virtual races as well. It's entirely possible for you to train a model on a track and then use that model on a different track. It really just depends on what did your model learn and what did it focus on while it was training. So if you think that you have a really difficult track and that your model should be able to master any other track if it can drive on this track, then that's potentially something to consider. For example, you may want to train a model on Shanghai and then race on reInvent, and we've done this certainly in the virtual world. So what I'll do is I'm going to go and select Toronto Turnpike Training and scroll down. And the next section that we get to is called the action space. Now, this makes sense. If you think back to what we spoke about, pardon me, for reinforcement learning, we have our agent, and it's driving around in a virtual environment, which is represented by our track, and it's deciding to take actions based on what it's observing. And so here we provide that action space, listing the possible actions that our agent can take. And so we can see that we have something called a maximum steering angle. And so this is sort of just to the left and to the right, what is the maximum steering angle? And then obviously we can say, well, do we want the car to only go 30 degrees, 0 degrees, and then 30 to the right? Or do we actually want some interim steering angles as well? And so we have, let's say, 30 or minus 30, minus 15, 0, and then 15 and 30. One thing to keep in mind is that obviously as you increase the action space, it'll typically take your model longer to reach a point where it's starting to converge. So that can have an impact on training time. Another thing that can have an impact on training time is the maximum speed. You obviously want to build a model that is fast. So to do that, you would go and select like, what is the fastest speed that I can choose? But in doing so, you should also know that models that run really hot and really fast take a very long time to converge. There's a whole lot of gray space for this car to figure out how to actually get to that optimal driving behavior. So if you train a model at a maximum speed of 1 meter a second, it should be able to converge quite quickly, in all honesty. Let's say an hour. If you train something at 8 meters a second, I would venture that your model needs to train for at least 3 hours, if not more. And so that's something you need to consider. The second thing is the speed granularity. And this is basically, are you providing one speed level? For example, I want to train my model at 5 meters a second. Can my car only go at 5 meters a second? Or do I want it to also be able to go a bit slower? 5 meters, 2.5. This is just a nice graphical interface for you to see, visualize what is the actual action space that your car will try and learn. And so I'm going to settle for 30 degrees steering angle, 5 steering granularities, a maximum speed of 5 meters a second, and speed granularity of 3. Now we get to the fun part, the reward function. And so the reward function is really the item that, as we said before, provides the logic for the car to determine whether an action was good or bad, based on the outcome of the action. It's used to incentivize that driving behavior that you want your model to perform. Like I mentioned, we have a couple of examples here. We have reward function examples, which if you open it up, you will see the default follow the center line. You will see another example called stay inside two borders, where we basically just say, if you're in the middle of the track, or rather between the white lines, that's good. We also have something called prevent zigzag, which, interestingly enough, we have noticed that sometimes when we train a model to stay between the white lines, it does that perfectly well, but you can stay between the white lines and follow a straight line, or you can stay between the white lines and zigzag across the road. Now, the one will take a lot longer to complete a lap than the other. And so here what we're doing is we're actually actively going out and we're penalizing the steering. So if the car steers at that 30-degree angle, we actually say, that's not desirable. So we scale down the reward. We don't want to completely ignore the 30-degree steering angle, because in some instances it is very useful. For example, if the car needs to turn at 30 degrees as opposed to going off track, then clearly a scaled down reward is still better than no reward. For today's example, I'm just going to use the basic center line. And so if I'm interested in understanding all the different variables that I can use in here, if you want to go and use, you can turn to the AWS DeepRacer documentation. You can look at the GitHub page that we're going through now, or you can look at the information section, where we basically provide you the definition of all these input parameters. And you can use these to craft any logic that you think would be useful for the car in figuring out what is good or bad behavior. And just before I move on, the important thing here is the reward. Like, you should reward the car if is exhibiting the behavior that you think is the most useful or most practical in racing around a racetrack. And so if we look at this example, we say if you are within a certain distance from the center, a very close distance that is, we'll give you a reward of 1. If you are a bit further away, we'll give you 0.5, and if you're out beyond that boundary, we'll give you 0.1. And just so we don't have any rewards of 0, we'll say, well, always initiate the rewards at like 0.003 or 001 rather. Next, we'll go into hyperparameters. So I mentioned these are pretty useful. I am not going to go into all of them in detail, but there are a few that I do want to call out. And the first one is the number of epochs. This item determines that when we train our model, how many times do we want to run through all of the experience we just picked up? So if, for example, if my car completed 20 episodes, how many times do I want to push those episodes through my model to try and improve the model? And so we typically start off at 10, but I've been playing with a setting of 5 lately. And also learning rate. Learning rate is something that determines when my model is training, how quickly should it learn. The risk here is that if you have a really small learning rate, your training will take a very long time to converge. If you have a large learning rate, you may find that your model is struggling to converge on the best behavior. So something I've been playing with is training a model for a shorter period of time, for example 60 minutes, then looking at my training results, and I'll show that to you now, and then cloning my model and kickstarting it again, and perhaps decreasing the learning rate if it seems that my car is getting stuck at some point. So for now, for your first model, maybe what you should do is just set a learning rate of 0.001. And then I think the last item that I want to discuss is the number of experience episodes between each iteration. This basically says how many times should my car attempt to complete a lap before I start updating the model. And here we say 20 times. If my car has left the track 20 times or managed to complete the track 20 times, that is sufficient experience for me to go and update the model. So initially these training iterations happen quite quickly, and you'll see that in the logs, and later it takes a bit longer. I'm going to leave this at 20 for now. And so the next thing we have is what is our stopping conditions. I think important to call out here is that it's going to take your model about 5 to 10 minutes to start training. So do not specify something as short as 5 minutes, because it won't really give you a good model. What I would suggest is that under the current learning rate of 0.001, set a training time of 60 minutes, and then we will start training. I'm going to start training now. And on this screen we can see that it's busy creating the required containers in the backend. That's basically spinning up a SageMaker container, spinning up the AWS RoboMaker container. We will run the simulation, make them all talk to each other, and then once everything has been set up in the cloud, it'll start collecting the experience, and you will see a video pop up of the cars driving. Now, I'm going to jump back to the screen shortly, but while we're waiting, let's quickly take a look at when you've done training, what does it typically look like? Let's take a quick look at some of the models I trained. You'll see I typically try and name my models based on my training parameters, and this is just for me to make sense of them when I come back to them. So I've trained a model on the Shanghai track, and this is in a different account, which is why you can't see the training currently happening. But I've trained my model on the Shanghai track for 60 minutes at using 30-degree steering angle, 5 steering granularities, 5 meters a second max speed, and 3 speed granularities. I also increased the batch to 128 from 64. I used 5 epochs, and I made my learning rate 0.001. Basically, I used a larger learning rate. Now, when we go into our model, once it's done training, you will see a really interesting reward graph here. During training, you will actually see a training video, and if I can show you what that looks like, this is our test 1, 2, 3 model happening in the background. And it's busy trying to learn, but this is what it looks like after it's learned, after it's trained, rather. And what you will see here on this reward graph is these are actually averages. And it's not the average per episode, but it's the average per training iteration. So every time that our model starts training, we have these 20 episodes of experience, and we want to know, well, what was the reward for those episodes and what was the progress around the track? And so that's what these two lines represent. The blue line shows you the average reward, and the purple line shows you the progress around the track. Now, as you can see, my 60-minute model didn't really make it around the track. Well, at least not from an average point of view. But if I do go and look at the episodes itself, I can see, well, there was one where I got pretty close at 99%, but that was one in about 500 steps. So that's it's probably not good odds, those. So I can see that my model probably still needs to train a bit. I really want this progress percentage to go a bit higher, and I would like to at least see some laps where I complete my model. So what I would typically do in this case is I would go and select clone, and what that'll do is that's going to basically go and copy this model and just append a clone at the end of it, and it'll basically give me the exact same parameters as I used before. Now, if I feel like it, I may decide to decrease the learning rate a bit, but I think this model still has some to go. And I actually trained a model like this as well, where I cloned my 60 minutes. So let's have a look at the 60-minute clone to just see how that performed. Now, bear in mind, previously we saw an average progress completion that was stuck at somewhere, let's say, the 30s. Now we can see that on average, my model completes about 58% of the track. Now, if I go and look at the specifics now, I can see that there are far more laps where during this training iteration, my model actually completed the whole track. So I would say there's probably some chance that I can submit this model into the virtual league and go and race. Or if I want, I can go and clone it again and train it again. Now that would be the 3rd hour that I'm training this model. Well, I don't think I did that, but what I did do was I went and I originally trained a 180-minute model. And what we can do is we can certainly go and look at this one's results, and there you can see that this model has been rather consistent now. It's completing 100% the lap. Well, it can complete the lap with quite some ease. So what I'll do is I'm going to take this Shanghai and let's just go back and see. I'm going to submit this into the Cumulo Carrera, just because I don't want it to go and have an impact on the Toronto Turnpike. And when I click Submit Model, it's going to say that my model has been submitted. Currently I'm ranked 623rd. It's not the best models ever. And once this evaluation is done, it'll basically update my model results. Now, if my model time is faster than my previous models, then my rank will update. But if it isn't, the rank is not going to update. And furthermore, if it couldn't complete one lap successfully, then it's also going to show me an error message saying, your model was unable to complete the required number of laps. And what I would highly recommend in that instance is go and look at our Racing Tips page, and also go and join that Slack community that I mentioned, because that's where you're going to find really useful tips on how to build good models. So let's jump back into our training of Model 1, 2, 3. As I mentioned, on the left you will see this reward graph, and it's basically showing what is my average reward per training iteration, and we can see that there's been 1, 2, 3, 4, 5, 6 training iterations, which kind of makes sense because we've had 120 episodes. And from a progress point of view, my model has really not been able to do much. This is fine because our model has just started to train. And so what you really want to see is you want to see these progress and reward bars go up and to the right. And as your model starts converging, you will see that it can complete the track, pretty much 100% of the time, most of the time. Now we have a few other useful things for you to look at here, and that is you can go into RoboMaker itself and you can see the actual simulation happening. You can also go into SageMaker and you can have a look at the simulation as it's happening, the resources being used. And one of the useful things I pointed out on the GitHub was the log analysis notebook, which you will basically use the simulation logs to go and run. Now once your model is done, what you can do is you can evaluate it, or you can just go and submit it into a virtual race. So just calling out, once your model is finished training, please be sure to race in the Toronto Turnpike. This is your last chance to win a ticket to reInvent in the virtual circuit. And you can do that by submitting your model to the virtual race or going to DeepRacer virtual circuit in your console and then selecting the Toronto Turnpike. And that leads us to what is actually going to happen at reInvent this year. So we will have workshops throughout the week where you can interact with our solution architects that have been running DeepRacer races around the world and at our customers. You will take part in live racing happening at the MGM Arena throughout the week, and you can also take part, if you make it, into the Championship Cup final. Thank you very much for joining me today. My name is Clark Wenzel, and looking forward to seeing you in the virtual races and also at reInvent.